Okay, chapter 4, I take a look at the importance and uses of motion study. So don't feel bad if your textbook is like many chapters. Just take it as just a single panel, okay? And as a university student, reading it should be a piece of cake for you. You have practiced reading, right? To read incredible books. We were elementary, middle school, high school. You have to keep up with that rate, okay? Don't um don't forget about library system that we learned in high school. Weekly reading and reading assignments, and you gotta keep on doing that throughout your life. At university, the professors are not going to assign reading anymore. So the classes you're taking is your reading, okay? Is automatically have to do every week. So as university student, 1 hour of lecture. So right now we gotta get lectures online through the video lecture. So 1 hour you have to back up 2 to 3 hours of your own analysis and study on that subject. And that requires reading the textbook, reading the handout, do research on your own and at the library. It's better at the library, but then now we don't have time. So now we're just Googling everything on it. So, but just be careful. So meaning like researching online, okay? Just but the sources are, some of them are reliable, some of them are good, and some of them are just not good. So you have getting misconceptions and getting the unreliable sources. So for university, even though we recommend, okay, do research online, try to be smart about it. Also, it also depends on your ambition. So anyway, the key point is don't feel bad if your textbook, okay, has many chapters. You don't have to hit everything, okay? You only take the key points of that subject. Okay, so let's take a look at what is a motion study. We already know those are the techniques that we're hitting. And for manufacturing environment, and we have already studied lean Toyota production system in the previous chapter, right? Chapter 2, right? And there I taught you is to eliminate the waste, okay? And we're gonna design system, okay? In order to design a system, we're gonna eliminate everything that is not necessary so that the system is gonna run efficiently. So what are we gonna eliminate? We're gonna eliminate 1, defects. Number 2, we're not gonna produce, okay, a lot. So overproduction. We're gonna eliminate waiting. We're gonna eliminate non-utilized potential. Meaning like some people are lazy. They can do, they're talented. You are smart, every single one of you, okay, can do many things that you don't do. It's just right in there in your genes. Okay, so everyone can do something. There's potential. And if you don't use it, okay, you will become rusted. Just like you have to use your muscle every day exercising, if you use the muscle will go weak. Okay, just like that. You have talent, brain in your system. And if you don't use it, the potential will just go away. So same as that, in the company, we're going to get rid of, okay, non-utilized potential. So that means employee got to do the work, okay, got to use their talent. They have to use their skill, they have to use their knowledge, and you have to give them chances for them to be able to use their potentials. Okay, so we have to get rid of the non-utilized potential. Okay, so how do we do it? Not like firing out people, not like that. We're trying to train employees, okay, so that they can be able to use their own talent, skill, knowledge, and empower them, give them opportunity to practice that instead of structuring them to stay formed. Okay, you don't have to be afraid in well-designed organization or company. Okay, so nowadays companies are very educated. We design in this way so that you can shine. So that's what we're talking about. Eliminate the non-utilized potential so that you will be giving everything you've got to company. We're going to get rid of transportation that is not necessary. So unnecessary inventory, excess product, gotta get rid of it. Pollution, unnecessary event, gotta get rid of it. Extra processing, okay, in the manufacturing environment, unnecessary processing or activity, we want to get rid of it. Okay, so our technique is getting rid of everything that you use, everything that is not valuable, everything that is necessary, and we will systematically eliminate them. Yeah. All right. Macromotion. So that's we're gonna cover in detail in next chapter. So here, if you get the name, I'm quite happy. So it's used for, we use this macro study and motion study to trace the object, the person, the information, the money, energy, and other things on the shop floor. Okay, so it is especially used to chart. Again, just drawing. You're gonna draw the activity flow, okay, of the product that we're producing. Macro, again, big motion, big motion, so that you can see. Anyway, we'll get into this in chapter. Alright, so what do we do? First, study the process activities. Process activity, okay, is gonna generate the process, or it's gonna run the process. I should say run the process. So we have 5, right, classes of activities. Operation, transportation, inspection, delay, and storage. They come with their own symbol. So when you go to a manufacturing plant producing something, you're going to see these symbols, right? And they are process chart symbols. And we are studying the process activity to run the process. They look like that. Operation, inspection, transportation, delay, look the D, and the storage. Because if you see a little circle, your activity, okay, is operation. You see this, oh, so we're doing inspection. You see that something is being transported. You see this, maybe we're checking the machines or delay. You see that, we're storing something. Okay? Need to use a symbol because some of the plant, it's noisy, okay, and so stressful. There's heat, temperature, vibration, and noise. Okay, the environment, manufacturing environment is a hush environment. Okay, tough people. Man, women also can survive, and women gotta act like man in a manufacturing plant. Okay, and again, our communication with signs, symbols, and lights. Yeah, colors also. So something that you can see, right? Sometimes you can't hear because of all the noise, production noise. It's gonna kill your ear. So anyway, because you're always surrounded by big machines, yeah, in the system. So this is our first study, the process activity, and pay attention. Okay, process or activity, and we usually use the symbols when we draw the chart. Second, we study the purpose of each activity. So how do we do it? First, we're going to use a method of study. And in this method, we ask, okay, questions. Two ways that we can do. The very first one is you ask 5 times why and why and why and why and why do this activity. Second one is we ask 1 to 5 different questions. Who, the, what is going on, when is it happening, where is it happening, and why we do it. Okay? But anyway, it depends on activity. Okay. So 2 method, okay, that we do is asking 5 whys or asking 5 different W questions. So by doing that, what do you get? So by asking this question, by asking 5 times why, you come to understand the activity thoroughly. So we focus on each activity. Again, what you're doing is studying. Studying means trying to know something. You're trying to understand something. Here you're trying to understand an activity. If you do not understand the activity, it is impossible for you to control that activity, repair that activity, or fix the activity, or improve the activity. So therefore, you need to understand. In order for you to understand, you have to study. Studying, again, is watching, listening, asking questions, repeating, doing, okay, and then do all of that processes again and again in order to understand some inside out. Okay, so here, use a simple method. In this method, to understand the activity, study by asking questions. One is asking 5 times why. The second one is asking who, what, where, when, and why. And by doing that all the time, doing that every day, you come to the complete understanding of that activity. Alright, next one. Third one. We're going to study potential improvement. So how do we do that? We're going to do 1 all the way to 4. How do we do that? We consider them, okay? Then after we consider the form group sequence, what do we consider? We think, can this activity be eliminated? Okay? If not, you're gonna think, can this be combined and done with another activity? So you're saving time, right? Eliminating, you're reducing the cost. Yeah. If not, you're gonna think, consider, can this be rearranged, okay, to occur in the sequence at and easier time? you rearrange it, combine it, eliminate it. Can you do all of that? If not, think, can this be specified with shorter distances? So save time and money right there again. Mechanical says, or reduce complexity. If you can run things, simplest way, most efficient, simplest, shortest, way, then you will definitely be saving time and money, yeah? And you can improve the system, all the sequences in the system. So that's what we do in the third step. Again, we study the activity inside out, study how to run the activity, study how to eliminate, combine, rearrange, or if you can simplify it. Yeah. Finally, draw a chart so that you can organize your thoughts and your observations and your findings. And we put them in a diagram so therefore you can systematically see it and can be able to get what you have studied in an efficient way. And since it is a diagram, right, it is showing you systematically so that you can be able to think how to do the activity. So first you study step by step by using certain methods, and second, organize findings, usually by making graph, diagram, draw a chart. Okay? Those are systematic, okay, so that you can extract and plan or come up with a strategy to do this. Make it everything easy, you know? So what kind of chart do we make? Okay? We use process flow chart or plan. We also use a process operation chart. We use a simple process chart. We use a flow. This one is a flow. See, right? The process chart. We can also draw Excel chart or the sheet. So different kinds of charts that you can draw, okay? To take a look at the design motion study, design, so that you can improve or maintain that design. Usually it's improved. Why do you have to do a lot of improvements? The company is not the same. It's really fluid. Again, it's a fluid. It's a fluid. It's composed of different bodies at different time. Yeah. Okay. Then after the macromotion, we do micromotion. Details. Right? Again, studying, trying to understand this motion in details. This is a little motion, small motions, okay? Trying to study. Again, we will go in details about micromotion in chapter 6. So here, just trying to know what this is about. So micromotion is a little bit different from macromotion. This going into small motion, okay, motion elements activity. So this study is we use it in highly repetitive operations. Infrequent, in other words, is sporadic setup and maintenance procedures. Okay, so these are the activity that we use in micromotion study. So we study the highly repetitive operations, we study the infrequent setup, and we study the maintenance procedures. So why do we have to do micromotion? It's because in manufacturing flow, right, waste, a considerable amount of waste happen in motion and also in idle time. Okay, happens during the operation and all on-process operation. So this idle time and considerable waste in motion, they happen during operation and on-process operation. Okay, so therefore we do this type of micromotion study. And don't forget, we are eliminating waste. Okay, we are eliminating everything that is not necessary in our system to increase profit, to reduce cost. So repetitive operations are, like this, the operation is repeated and it's highly that you have to be so careful that they keep running. Okay, and that's why you need to study in everyday work shifts. Infrequent setup can create incredible interruption, and this is kind of difficult to be able to understand. You might think like the setup is infrequent, so what's the deal, right? What's the problem? Infrequent setup is not the same as frequent setup. Frequent setup is, habit of doing it, so therefore it goes faster. Infrequent setup. So it's a little bit different, but you don't have to worry about it anyway. If you can understand, like we do this type of study in repetitive operation and infrequent setup, fine, and our maintenance procedures. Okay? Maintenance procedures also in manufacturing industry, you want this and preventive. Okay, you don't want it, and you don't want it reactive. So therefore, we always make sure that maintenance procedures are done before run the operation. Okay, run maintenance procedure when the machine breaks down. Make the machine healthy at the time. Maintenance is kind of like a doctoring. It's kind of annual checkup, not to emergency, right? Since you check yourself out annually, so manufacturing industry makes procedure a preventive, so proactive. They make sure that the system is healthy at the time, and like doctoring system is on the maintenance procedures that's been done for running the system. So anyway, that's what we do in micromotion study. Why do we do? To get rid of waste and to reduce the idle time. Right, next. Here are some steps that we use in the operation charts. Okay, so operation analysis, we're analyzing the operation. Most of the operation you have operator and machine. So therefore, do operation analysis, and we do operator machine analysis. We do Gantt chart, we do multi-machine chart, and since you use your left and right hand, so left-right chart. We also use the sine chart to study the stress on your. Anyway, so this is an example chart that we use. Okay, it's a type of operation chart. Sine chart. Example is, and this is showing okay what kind of operation, name of the person, And then we're looking at operators left hand, right hand. And these are just a symbol. That's how much time it takes. These are the symbols of the activity that this person is doing, okay? And this is how long it takes. So it grabs the cheeser, jaw position, and we use the symbol chart in study kind of tension and stress that operator get by doing this, okay, that long. So if you think like 10 winks, okay, it's just a unit of time. It's a couple of seconds. You think like there's no stress on your hand. You're doing this repeatedly. Okay, I said it highly repetitive work in a previous slide. So you're doing that every day, 8-hour shift or 10 or 12-hour shift. Okay, in a week. Then we have a series of that weeks in a year, and then you have years of experience. So of course your hand is subject to that amount of stress in that many years. And that's how we study the micromotion, highly repeated processes or actions. And after we study, we record like this. So when we record the charts, so that history is going to be systematically filed. So you can use the data to improve, okay, that operation all the time. Okay, doesn't matter how many different kinds of diverse operators work that your company know to do, how to fix. Right. Now we're getting back to the same thing on analysis. So motion study, again, going to save large percentage game cost than anything else before. So it's very important. Cost reduction. Motion is a design cost reduction. Design is used to design a job, design an activity at work, to build workstation, efficient workstation, train operator to make time study. Time standard come from time study. What is it? Again, it's a time required to produce a product at a workstation with action. Okay? We are studying, measuring the time it takes to produce a product. Not the entire production line. It's at a workstation. Look at the condition. The very first one is a qualified, well-trained operator experience a time with job. Second one is working at a place, a one-time standard job, regardless of operator differences. We're gonna just go single standard to any kind of operator. Doing a specific task, a detailed description of what must be accomplished here. So specific task, you have an experienced worker, a normal pace. So those are 3 conditions. Take a look at it. Do this time standard. Doing a specific task, take a look at prescribed method, material specification tool, position of material, safety, quality, housekeeping, maintenance tasks. So all of this 1 to 5 is what we consider when we study a particular activity task. Okay, we take a look at that. So when you're studying a task, you take a look at what's the method, what are the materials, take a look at tools and the at that work. You look at the incoming and outgoing material at that workstation. Okay, and we take a look at the safety, quality, and housekeeping and maintenance tasks at that workstation. pieces at the workstation operator. Okay, so what we do when we study form time standard. So let's take a look at the example. So mathematically you understand. So we have a job, and our standard for that job is you have to produce, okay, one piece in a minute. So operator is expected to produce 60 pieces in an hour at one piece per rate. Okay, so there are 60 minutes in an hour. So therefore 1 minute is equal to 0.667. How do we get it? 1 minute divided by 60 minutes. So minute is going to cancel out times 1. So the 1 minute, okay, is equal to 0.1667 hour. So 0.1667 hour is 1 minute to produce one piece. So one piece takes 0.667 hour to be produced. Okay? If you want 100 pieces, it should take on 16.67. So one piece divided by 1,000 piece is going to cancel out time 0.667 hour is going to give you 16.67. To produce 1,000 pieces. Okay. So your time standard here is you should spend 2 work day at 8 hours shift to make 1,000 pieces, and that's your production rate. Okay, we don't know what they're producing. They only tell you it's a piece, and this is not the final product. They don't. This is a workstation using a product. But there are many workstations, okay, in a production line making that product. So this time standard is happening at station. And 1,000 pieces gotta go through at 2 8-hours shifts. So 2 8-hour shifts is approximately 16, right? Hour. So about 16.67. So 67% is standard deviation, plus or minus. So if you're producing only, let's say, 800 pieces, okay, in 2 days of your work, you're not at a performance standard. So therefore, you might be on a layoff list, okay, or you might be on schedule to get fired out, or you might be on a corrective plan to come up with 1,000 pieces in 2 days of your at 8 hours on a day shift. Yeah. Okay. So now you get an idea of why we do time motion study to come up with standard. We record the standard, accumulate different observation, different monitoring system, and time we're gonna come up with historic, acceptable, and standard. Use it to measure your value, and then we use that again to come up with decision, okay, for your importance and uses of time study is one of the most important pieces of information, right? Especially for manufacturing department. That's why we gotta study to come up with that information. But we use it heavily to judge employees to make decision. Company. So we use it to answer main problem. One is determining the machine and tools to buy. Right? So if you have a bad machine, you can't be able to make expected pieces or parts at that workstation. You have to determine people to employ. You have to determine between costs and selling prices. You have to schedule machines, operations, and people to do the job and deliver time plus inventory. For all of that is important. For all of that, we use the time study. Then we determine the line balance, determine the conveyor, belt, the speed, loading the work cells with the correct amount of work. You don't want to overload, and balancing the work cells. Balance correct amount. Now the balance speed, so important in manufacturing. Determine the individual performance. Identify operations that are having problems so the parts can be corrected. Pay incentive wages. You have to report you are up the standard and for outstanding team are overachiever. And they can do 3 to 4 people's work. And you definitely need to give them incentive. Their work is excellent. So again, 5, 6, 7 with 1 to 4 in the previous slides are the uses of time study. 8, 9, 10. Next one, we evaluate the cost reduction ideas, picking the most economical method, and that's got to be based on analysis, not your feeling, not your opinion. It's got to be based on data. So the bias-free data is so important, and that's only coming from study or research. Evaluating the new equipment purchases to justify their expense. We gotta reduce it. Equipment is so expensive, in manufacturing. It costs like $1 to $2 billion. So you know, to make that kind of decision lightly, to analyze, and you have to study to evaluate expensive equipment in manufacturing environment. The manufacturing environment is a multi-billion system. You don't want to make decision on your opinion. It's very dangerous. So you're developing operation personal budgets to measure the management again performance. Management is critical. Company, because if they perform bad, this is more crazy. So 8, 9, 10, in addition to 1 to 7 in previous slides, for uses of time study. I'm not going to ask you if you can come up 50%, I'm okay with that. Techniques, time study. This is reiterating the same. So PTSS, going to cover that in chapter 8. Stopwatch, chapter 9. Work sampling, chapter 11. And standard data, chapter 10. These are just a single handle there, or handle. It's not a big deal for you. Alright, so that's it for this chapter.